The builder design pattern is a creational pattern used in software design to construct a complex object step by step. It allows the construction of a product in a step-by-step manner, where the construction process can change based on the type of product being built. This pattern separates the construction of a complex object from its representation, allowing the same construction process to create different representations. Below are the steps to implement builder design pattern. Create the product class, define the object, product, that will be built. This class contains all the fields that make up the object. Create the builder class. This class will have methods to set the different parts of the product. Each method returns the builder itself to allow method chaining. Add a build method in the builder class. Add a method called build or similar that assembles the product and returns the final object. Use the director, optional if needed. You can create a director class to control the building process and decide the order in which parts are constructed. Client uses the builder. The client will use the builder to set the desired parts step by step and call the build method to get the final product. In builder design pattern, we first create a product class. This class has private variables like CPU, RAM, and storage. We have public methods that can set values to these private variables, and those methods are setCPU, setRAM, and setStorage. Next, we have builder interface called builder. In this interface, we have virtual methods called buildCPU, buildRAM, buildStorage, and getResult. Next, we have concrete builder class called GamingComputerBuilder. This class inherits the interface called builder, and it provides implementation for methods called buildCPU, buildRAM, buildStorage, and getResult. It has one private variable called computer of type computer class. Next, we have class computerDirector. This class has one constructor which will take a builder object and then it will call the methods buildCPU, buildRAM, and buildStorage. Since we call this method, it will execute the code inside those methods, and this will in turn call the setCPU, setRAM, and setStorage method respectively, which will do the setup work for CPU, RAM, and storage. In the main method, we have two variables. One is of GamingComputerBuilder, variable called gamingBuilder, and next we have computerDirector, variable called director. Then we call the constructor of director and pass gamingBuilder, variable holding GamingComputerBuilder object, which then builds the parts of objects by calling methods like buildCPU, buildRAM, and buildStorage. Once the object is created, we call getResult method on gamingBuilder. In the final code, we see that we have computer class with public method setCPU, setRAM, and setStorage, and we have private variable CPU, RAM, and storage. Next, we have builder interface, which has abstract methods as buildCPU, buildRAM, buildStorage, and getResult, but they don't do any real work. Next, we see that GamingComputerBuilder inherits the interface builder, but builder does not do anything on its own. Since the GamingComputerBuilder inherits builder interface but builder does not do anything on its own, the builder then uses computer object which is assigned to private variable computer inside GamingComputerBuilder class and then calls setCPU, setRAM, and setStorage inside buildCPU, buildRAM, and buildStorage respectively to build the computer object. Finally, computerDirector is the class which will build object. The computerDirector has a constructor which takes object of class GamingComputerBuilder inside builder variable and it calls buildCPU, buildRAM, buildStorage on this object, and thus the object is built. Finally, we see that in main method constructor, is called on the director object which builds the computer object inside GamingComputerBuilder object, and then we get computer object by calling getResult on GamingComputerBuilder object,